All right, so I got a couple of rational expressions here, basically fractions with algebra. And the goal here is to write this all over one denominator and then simplify it if possible. So this one's pretty straightforward because the denominators are already the same. I can go ahead and add the numerators. All right, so my denominator is going to stay a 4x, and then I just need to add up the terms in the numerator. So I get a 3x plus a negative x. That's going to be a 2x. And then a negative 8 plus an 8, that's 0, so it cancels out. So this is what I'm left with. All right, 2x over 4x. The x's can cancel, and you're left with 1/2. All right, that's the end of that one. Let's say we had one that was, we'll go with 2x plus 3 over x plus 5. This one's a little different because it's a subtraction. There's something to pay attention to whenever it's subtraction. Okay, and then x plus 5. Again, the denominators are the same, and that's a good thing. So I know my denominator is still going to be an x plus 5 over here. Now, when it's subtraction, you got to make sure to distribute the negative, all right? So I'm actually just going to approach it the same way I did the one on top. I've got a 2x, and I need to minus an x. So that's going to be 1x. And I'm also going to be doing this 3 minus the negative 2. All right, 3 minus negative 2 becomes a positive 5. And that's it. What you wind up with here is you got the same thing on top and bottom, exact same thing. So this whole factor cancels with that whole factor, leaving you with one whole. All right. Let's go with 3x plus 1 over 4x plus 1 over 6x squared. All right, the denominators are not the same, so we're going to have to force them to become the same. All right, so you want to take care of your variable parts and your coefficient parts. The 4 and the 6, the common denominator or the least common multiple for 4 and 6 is going to be 12. Notice if you do 4 times 3, you get 12, and if you do 6 times 2, you get 12. So I'm going to take this one and multiply top and bottom by 2. And I'm going to take the one on the left and multiply top and bottom by 3. All right, that way I wind up with a 12 for the bottom number. And then I also need them to have an x squared, it looks like. This one has an x squared. This one just has an x. So the one on the left, I need to multiply top and bottom by x as well. All right, this will take care of it. So I'll just, I'll do one term down below. So the one on the left, that's going to give me a 12x squared. And then I need to do 3x times this whole binomial on the right, distribute that. That'll give me a 9x squared. 3x times 1 will be a 3x plus. You get a 12x squared again. And then 1 times 2. All right, there's not much to do here except go ahead and combine the numerator. The denominators are the same now. 12x squared, and we're just left with 9x squared plus 3x plus 2. All right, so there's no common numbers between all the terms, and I can't factor anything out of the top. I mean, you could check to see if the numerator is going to factor, but in this case, it will not. Like, I can't write this expression as the product of two binomials. It's not going to happen. All right, but check for that. Is that one? I do believe it is. Okay, good. All right, so this one, I've got an x plus 4 and an x. I need these to have the same exact denominator. What that boils down to is that they have to have the same factors in the numerator and denominator. So I'm not able to just add 4 to the bottom and add 4 to the top. that would not work. What I'm going to do is I'm going to multiply the 1 on the left. I'm going to multiply, oh, I don't know why I wrote it like that, but anyway. I'm going to multiply the expression on the left by x over x, and I'm going to multiply the expression on the right by x plus 4 over x plus 4. All right, x plus 4, x plus 4. Okay, and now we'll go ahead and actually distribute some stuff. The denominator, though, I'm actually going to leave that in factored form. So this is going to be x, oh, a little space. The denominator will be an x, and then x plus 4. Now the numerators I actually need to distribute and multiply out. So x times x will be x squared. X and a 2 will be a minus 2x. Plus, we got the same denominator over here. And then distribute my 6 this time. 6 times x will be a 6x. 6 times 4 will be a 24. Okay. And now I can put it all over one denominator. And I'm going to leave it in factored form here. X and an x plus 4. The only common terms are going to be these two in the middle. So it's x squared. That'll be a plus 4x and a plus 24. All right. So if possible, we want to check to see the numerator will factor. It will not. There are no two numbers that multiply to 24 and add up to give us 4. So this is where I would stop, and I got it all as one fraction, one rational expression.